Welcome! We're going to break down descriptive statistics today. Think of this as your pre-game prep before you dive into the readings. Our goal is to really get the why behind all the techniques so you can see the big picture and the story your data is trying to tell.
So picture this. This right here is the fundamental puzzle in pretty much all research. We've got information from a small group, our sample. But what we really want to do is make big claims about a much larger group, the whole population. Statistics, well, that's the bridge that lets us get from one side to the other.
You see, the whole point of our analysis isn't just to talk about the 1,000 people we happen to survey. The real magic word is inference. We're trying to make smart, educated guesses about everybody else. It's all about using what we know to understand the much bigger world of what we don't know.
All right, here's our game plan for today. We're going to start with the big idea, then we'll tackle the biggest challenge, which is uncertainty. We'll look at the tools you need to describe your data, see how to get the numbers in PSPP, deal with a super common problem with data, and then, the best part, learn how to turn it all into a compelling story.
So let's kick things off with that main goal. Like we said, it is all about making that leap, right? Taking what we found in our little sample and applying it or generalizing it to the entire population.
But, and this is a big but, that leap is never going to be perfect. Our sample, no matter how carefully we pick it, is never a perfect, tiny mirror of the whole population. This creates this kind of statistical fog, an uncertainty that we absolutely have to be able to measure.
And that difference has a name: sampling error. See, in a dream world, our sample's average would be exactly the same as the true population's average. The sampling error would be 0. As researchers, our job is to get that error as tiny as we possibly can.
Okay, but wait a minute. This sounds like a bit of a catch-22, doesn't it? How on earth can you measure the difference between your sample's average and the true population average, a number you almost never actually know? I mean, if we already knew it, we wouldn't need to do the survey in the first place.
And this is where statisticians get really clever. The solution is a brilliant little tool called the standard error. Since we can't know the real sampling error, we calculate our best guess of it, using only the data we have from our sample. You can think of it like our compass for navigating through that fog of uncertainty.
Look, if you remember one thing from this whole discussion, make it this. A small standard error means we're feeling pretty good, pretty confident that our sample is doing a decent job of reflecting the population. A big one, well, that's a red flag. It's a warning that our results might be a little shaky.
So to get that all-important standard error, we first have to really understand the basic shape and feel of our data. And for that, we've got a specific toolkit of descriptive stats.
We usually start with what I call the 3 M's. You've got the mean, which is just the plain old average. Then there's the median, the value smack dab in the middle, which is super useful because it doesn't get messed up by a few really high or low numbers. And finally, the mode, which is simply the most common answer you got.
You can think of this as a logical path, kind of like a recipe. It all starts with variance, which is a way to measure how spread out all your data points are. Then, from there, we get the standard deviation, which makes that spread a lot easier to understand. And that standard deviation leads us right to our final destination, the standard error.
Okay, theory is awesome, but let's get practical. How do you actually get a computer to do all this heavy lifting for you? Let's take a look at how you do this in a program like PSP or SPSS.
Now, when you open the menu, you're going to see a few different options. But here's a pro tip. Just trust me on this one. For the most complete, most powerful, most useful set of stats, you almost always want to use the Explore command. It gives you pretty much everything you need all in one go. And using it is pretty simple. The main variable you're interested in, say years of education, that goes into the dependent list box. And if you want to compare that variable across different groups, like different social classes, you pop that grouping variable into the factor list box. Easy enough.
But, sometimes just running the numbers isn't the whole story. What happens when your data gets a little weird? I'm talking about a few extreme values, what we call outliers. And these things can pull your mean, your average, in a totally misleading direction.
I mean, just look at these. At first glance, the averages seem fine, but when you look at the actual charts, you see that for both of these, most people are clustered down at the low end. It's just a few extreme cases that are dragging that average way up, making it not very representative of a typical person at all.
The standard deviation here is the dead giveaway. The mean is 5.4, but the standard deviation is a mind-blowing 17.7. That is a massive flashing red light telling you that your data is incredibly spread out, and it's almost certainly because of outliers. Like, I don't know, the one person who claimed 700 partners.
So what do we do? Well, one thing we can do is remove a tiny percentage of the most extreme cases and just look at the effect. The mean drops to a much more believable number, and the standard deviation just plummets. This is huge because that gives us a much smaller standard error, and that means a result we can actually trust. All right, we've gotten our heads around the theory, we've crunched the numbers, we've even cleaned up our data. Now it's time for the final and honestly the most important step, actually communicating what we found.
The software is going to spit out a big table that looks something like this. Now don't let it intimidate you. You just need to zero in on the key numbers, the mean for each of your groups, the sample size, that's the N, and the 95% confidence interval.
And this is how you turn that table into a story. You state your finding in plain English, you provide the key numbers to back it up, and you include that confidence interval to be totally transparent about your uncertainty. This is how you write like a social scientist.
And here is a fantastic pro tip for you. Those confidence intervals, they're more than just numbers. They are a quick and dirty test for significance. If the intervals for two of your groups don't overlap at all, that's a really strong sign that there's a real difference between them out there in the real world. So, we've cleaned our data, we've run the numbers, and that gives us more confidence. But that brings us to one final, really crucial point. Statistics are an amazing tool, but they are not a truth machine. You always have to step back and ask yourself, are there other, deeper reasons why this result might still be misleading? Keep that critical mindset as you dive into your readings.